Assalamu alaikum warahmatullahi wabarakatuh. We are going to just start the new section in our linear algebra, and that's our discussion about the vectors. It's a very important one, and this is being used all over in the physics, in other subjects in engineering, heavily used. And we must have a very clear concept about that one because we are using it to describe many different things and for calculations also. So we must know basically the difference. There are two quantities. One we say vector and other we say scalar. So the basic difference between these two is a vector is a quantity which have magnitude, also the direction, and scalar is a quantity is having only magnitude. In addition to that, I just want to mention it that most of the calculus books are having this chapter 10. If you open any of the book, most of the book have the sequence. In that one, it's come 10 or 11. So we'll get it from there. So we are going to study it, and we'll just going to discuss the algebra of that one, and then the next chapter will be about the vector value function. We define this as a function, and after that we also at the same time we discuss the calculus, the derivative, and all other things. So inshallah you will enjoy this one with me. I am just going to take very simple way to make these things clear to you, and so that you can understand. Main thing is the understanding. So as I said, when we say the vector, so vector is having two quantities. We say it's having magnitude and it has direction. When it's a scalar, this is scalar quantity is having only magnitude. We in physics and also in our engineering, we having different quantities. We say these quantities are the vector quantities, and they are the quantities we say these are scalar quantity. Physically, we can see like this one. For the vector, we say our mass is a scalar. Then we have weight. Weight is a vector. Weight is the pull of gravity. There is a direction also. Then we can have the speed. Our speed is a scalar. But we are having velocity. Velocity is a vector. It's having the magnitude, also the direction. And similar to this one, after velocity, rate of change of velocity, we say acceleration. Also, this have the direction, is the rate of change of velocity. Then we go further, when we define force, force is equal to mass time acceleration. So all type of forces, they will come in the vectors. So we say all the forces will become in a vector. So the vector quantity. When we say temperature is a scalar quantity. Similarly, we can have time. Time is also scalar quantity. When I want to show it in mathematics, then you say I have a line. When you see the vector, so vector is having a line which is having the length and the direction. This is length, magnitude, and this is the direction. And here scalar is only the length. It does not have any specific direction. When we want to show it mathematically, so we are having 2 points for this one. We say a point P, we say that's the initial point, and we're having point Q. Point Q we say is a terminal point. And we defined like this one. This is my point P to point Q. This is my point P, initial point, and this is my point Q is the terminal point. And we say my PQ, and I put here the arrow is my vector. So this can be in 2 dimensions, it can be in 3 dimensions. I will just explain you in 2 dimensions. For example, we're having this plane. This is my x-axis, this is my y-axis. So I have this my length x. We say this is my small a, and this is here my b, small b. And then I have the point here. This my point is a and b. This is my origin 0. I just join it with the a. So this I say this is my vector a. So what's my vector a? My vector A is having components, I say A and B. So this I say the vector in 2 dimensions because we're having x-axis and y-axis. I can write in a different way. When you're having the point I write it like this one, AB. I have the vector, then vector I write in bracket like this one, A, B. So then we are having here the concept which you know is not the new one, it's something new which I am going to teach you, that the unit vectors. The vector which is representing along x-axis is my I, and here along y-axis is my j. This I say etc. This means this length of this vector is 1. When we say I, we say I is my vector, my x is 1, my y is 0. Vector j is my x is 0 and y is 1. So this is a vectors in, we say, in 2 dimensions, because this point will be 0, 1. Sorry, this is here is x is 1. This point is 1, 0, and this point is 0, 1. And this way we can define our vectors. So we'll have different way of writing the vectors. We're going to study that one. So one thing which is clear, that we're having two things for a vector: is have magnitude, is have the direction. Scalar is having only magnitude. I gave you the example for the vectors. I gave you this example for the scalar. Then we have seen this thing, that we having a point P and point Q. Then point P is my initial point Q is my terminal point, and I join this one, and this become a vector because having this length and also the direction. So we say PQ is a vector. Then I have just give you the example that we can write in 2 dimensions. In 2 dimensions, we can just write this one. Show you this one. This is my vector A. I can take this one as along x-axis, along y-axis, as my unit vector, and I have mentioned say I and j. So we are going to discuss further about the unit vector and about that one. So just we go ahead and I just show you that we can just extend this definition for a 3 dimensions. And what for the 3 dimensions? That means I have the x-axis, y-axis, and z-axis. Now if I take here the 3-dimensional case, then I have here in 3 dimensions. It's little different from that one. This is my z-axis, and this is my y-axis. This is my z-axis, and this is my x-axis. And here is my origin. I want to take the point here, and I want to mention it, that we are having the point that is having in xy plane. Now in xy plane, it's not like that. For example, I have here this length is my a1, this length is my a2. So this will be the point, this parallel to y-axis and parallel x-axis. This point is a1, a2, and z value is 0. Now if I want to show this point in 3 dimensions, so I am going to take here this point above. From here, I am raising it. This is my z is changing. Here is my z is changing, and I am getting here. This is here. This point is a1, a2, and a3. This value along z-axis. So I join this point. This is my point A to 0, and this is my point P, and this is my vector OP, and I denote by A. So this, if I take this one, then I am going to show this value here. This is my A3. A1, the length along x-axis, A2, length along y-axis, and A3, length along z-axis. So here you can see I've just taken this point above in 3 dimensions. So this is my point in my 3 dimensions. And if I want to write the vector, so like that one, when you say the point will be A1, A2, A3. I want to write the vector. So vector will be the vector A, and this is my OP, and I denote by this brackets A1, A2, and A3. This is how I can show my brackets, this vector in 3 dimensions, how I can show this one, this vector in 3 dimensions, and this was here the vector in 2 dimensions. We can show like that one. Now I go a little further. Here I would like to mention also, as I mentioned in the last example, where the unit vectors. We say the unit vector along x-axis. This is my unit vector along x-axis, length is 1. This is my I, this is my j, and this is my k. So the coordinates here point is 1, 0, and 0. Here the coordinate of this point will be 0, 1, and 0. And coordinate of this point will be 0, 0, 1. Each is of length 1. Each is of length 1. So I can just write the point here, this point I. The point I, if I write like a point, this here 1, 0, 0. Point j is 0, 1, 0. Point k is 0, 0, and 1. This is a point. If I write as a vector, this is my point. If I mention this one like a vector, so my vector will be I denote it by, I just like to mention instead of I, j, and k, I just mentioned like this one, so we can have more better idea, because I will like I as a vector. So my vector I will be, this is the vector notation, 1 0 0. This is my j, this 0 1 and 0, and this is my k, this 0 0 and 1. I will discuss this one further, that this is set of unit vectors, is set of unit vectors in 3 dimensions. So further I will discuss further why you say the unit vector and further. No, I'm just mentioning it that if we're having 2 points, I have point A and point B in 3 dimensions. I have point A, the coordinates point A are 2, 1 and 5, and point B is point B is 3, 2 and 9. Find vector AB. For defining this vector AB, before that one, I would like to just mention the idea that how we write the vector when the 2 points are given. That's my A is the initial point and B is the terminal point. So the idea behind this one in general formula, for example, I have here 2 points in our 3 dimension, we say point P. So I have here point P. The point P, this one here is point P, and this point Q. So point P is having coordinates x1, y1, z1. This is my point P. And I have point Q. Point Q is having x2, y2, and z2. So I can write my vector PQ, where vector PQ is equal to x2 minus x1, y2 minus y1, z2 minus z1. I show you in 2 dimensions, that's more easy to show you. For example, I have here this point P. This point P is x1, y1, and here is point Q. Point Q is x2, and y2. So this is my x value, and this is my y value. So what's my x value? This is x1, here is x2. What is this length? This length comes to be equal to, as you can write here, this is my length, and my length is equal to x2 minus x1. And here I take this point. This is my y1, and here is the point, this one here, this is y2. This length, we get here, this length is equal to y2 minus y1. So if I want to write here this vector PQ, so my vector PQ will be equal to x2 minus x1, the x value, and then I have y2 minus y1 is the y value. This is in 2 dimensions. This is in 2 dimensions. The vector in 2 dimensions we can define like this one. Now in 3 dimensions we have this formula. So we are having here, this is in 3 dimensions. Here I write this is in 3 dimensions, and this is vector in 2 dimensions. So we have this formula. So this is our formula for any vector we want to write. It's very important to learn this one, that we can write any vector. So we can write here solution of this one, my vector AB. So our vector AB is equal to x2 minus x1. This is x1, y1, z1. This is x2, y2, z2. So we just take here x2 minus x1, y2 minus y1, z2 minus z1. My x2 is 3. This is here 3, x2 minus x1, y2 minus y1, z2 minus z1. So we just do this simple arithmetics. This here is 1, this is 1, and is 4. So my vector AB is equal to 1, 1, and 4. So we can have any given points, and from those points we can just define the vectors. We take an example that we are having here a triangle, and for that triangle I want to find the side of the triangle in terms of vector. This is my next example. Here is my example. We are having the triangle ABC. We having given here the triangle. This my triangle is ABC. This is my A. Vector is 0, 1, 5. This is my vector B. Vector B is 3, 2, and 1. is vector C. Vector C is 5, minus 2, minus 1. Find in triangle ABC, find vector besides this one AB, then we're having AC, and we're having BC. So I can write here now the vectors. I have the vector AB. This is my vector AB from A to B. I have given this vector. This is from A to B. So my vector AB will be equal to, this is here B minus A. This is my B, and this is 3 minus 0. 3 minus 0. Then y2 minus y1. With here 2 minus 1. Then here 1 minus 5, z2 minus z1. So get here this result as 3, 1 and minus 4. So next is our vector AC. The vector AC we are having from A, and we are having from A to C this side, and we write here our AC is equal to, now this is my x1, this is my y1, y2 minus y1, 5 minus 0, then x2 minus x1, y2 minus y1, minus 2 minus 1, then minus 1 minus 5, z2 minus z1, and we can just write here the calculation of this one. We can get here this equal to 5, minus 3 and minus 6. This is my side AC. Now I have the third one. The third one my side is BC. So this from B is my initial point, and my C is my terminal point. So sorry for that, not having nice drawing. So we are having here BC. So I write my BC. My BC, this is my x2, this is my x1, 5 minus 3, 5 minus 3. Then we're having here minus 2 minus 2, y2 minus y1, z2 minus z1, minus 1 minus 1. The result will get here 2 minus 4 and minus 2. So this is how we can define the vectors given with the 2 points, any 2 points. We can having just taken a triangle, and the 3 points we can just write by using our formula. Let's say our QP, the vector QP is equal to x2 minus x1, y2 minus y1, z2 minus, Q is a terminal point, P is the initial point, is from, we say from Q, and here from Q to P. This here x2 minus x1, y2 minus y1, z. So apply this formula and we can write the vectors here.